Hello and welcome to Meetup number 12, the Orleans virtual meetup with Jakub Konecki. How did I do?
Very well.
Good. We're going to talk about deploying Orleans and find out what Jakub does as kind of best practice, and hopefully it'll give us some ideas. If you have any questions, feel free to either type them into the Gitter channel that we've got going, which is gitter.im/.net/Orleans, or hit me up on Twitter or type into the chat here or interrupt Jakub mid-sentence. So we may well hear from some of the core team afterwards. I know Sergey's got a presentation that he may or may not present, depends how it goes. So I will stop there and let Jakub take over. You're
Okay,
able to
brilliant.
present your desktop.
Thank you. I'm going to share my screen now. Give me a shout if you can see it.
Yeah, just waiting, but it can take a little while on link. There it is. Yeah, I can see it.
Okay, I'm going to talk today how we are deploying Orleans application using yams. I work for the company called Applicita, and we have a very nice customer for whom we are building that distributed application. I would like to start with saying thank you to my boss and the actual product owner from the client side for supporting me in creating that presentation and allowing me to talk to you guys about how we are doing deployments on the project. If you need to get hold of me, the best way is Twitter or maybe drop me an email. I'm happy to answer any questions. So I want to start with talking a bit our technology stack. So we are using Orleans. All the backend code is implemented using Orleans. We are using actually Orlinka for a slightly functional way of defining our actors, and we are using Streamstone for persistence for our event sourcing actors. Most of our actors persist the state using event sourcing, and we store the data in Azure Table Storage. We use DocumentDB for storing CQRS projections and to help us with querying data which is spread between multiple actors. But in some places we use actors only, and we have some fan-out queries to get the data from several actors at runtime. We use Web API to expose the data, and we have an Angular front end which connects to Web API. When it comes to development and deployment, we heavily rely on Azure. We use Visual Studio Team Services, where we store all our code, where we have all our work items, and we use Visual Studio build services to compile and build our project. We use Octopus Deploy for deployment, and we use yams for actually hosting all our applications, with the exception of the website itself, which is published to App Service in Asia. So at the moment we have 4 separate environments, namely dev, test, UAT, and production. And we use Resource Manager, and we have a template which allows us to provision and the whole environment. When I say whole, that's probably around 95% of it. There's a few little tweaks that we need to do manually after provisioning the whole environment. That slide is about the monitoring. Ashkan asked me on Gitter to give a quick overview of what kind of monitoring we're using. So we use Serilog throughout the whole system, and we push all the logs to Seek when we can view the logs from all the environments. For Streamstone, we are persisting the information about the times that each read and write took, and we have the same telemetry for DocumentDB. So anything that goes out to table storage or DocumentDB, we know how long it took, so we can subtract that time from the time that it took for Orleans to process each message. And we have logging for every single message that every single actor processes in our system, so we can get the timings of the processing of each message. We also push some telemetry to App Insights, and we use a bit of Azure alerts. So, for example, when a CPU or memory on certain nodes goes above a certain threshold, we get an email. This is more to let us know if, for some reason, we have problems with deployment, or we've pushed out some code that uses 100% of CPU. We're not using any advanced, awesome monitoring telemetry things that you, Richard, and other guys showed us during the last meetup. But some of the telemetry there looks really interesting, and once we have some time, we would definitely like to use it. This is a very high level diagram of our infrastructure. So to begin at the very bottom, we use table storage to store all the events, and we store all our projections in DocumentDB. Both of those storages are geo-replicated, so we just turn on geo-replication for table storage and for DocumentDB. So in case one of the data centers goes down, we have that data replicated to a different data center. We have our Orleans cluster running on a few nodes, and we have our APIs running on a separate cluster in production. All of those applications are hosted on yams. So that backend code is sitting inside a virtual network, and we have a web app deployed to app service in the same data center, hooked up to the same virtual network. That one side of the slide is one of the environments that we have. So in production, we are using blue-green deployments. So we also have a copy of our infrastructure sitting in a different data center, which is not used at the time. So only one environment is live and running at a certain point in time, and we use Traffic Manager to route traffic from between those environments. So let's say that the West Europe data center becomes unavailable. We have the machines provisioned in our West US data center, which we can start quite quickly, and we can switch the traffic manager to point to a West US data center. The storage gets replicated by the feature of Azure itself, so we don't need to worry about duplicating or replicating the storage itself. So yams, we had some time ago a good talk by Neme about yams itself. I don't want to repeat what he said. So if you want to get a quick overview of what yams is, just go after this meetup to the other one, and Neme explains in great detail how the yams itself works. Today I'm going to talk about how we are using it in our project. So first of all, you need a yams host. So yams is a library. You need actually some executable that will be running and using yams library to deploy and manage the individual applications. So the code below is basically what you all that you need. It's taken from the yams documentation, and that's pretty much what we have, what we are running at the moment. The most important bit is using the app domain from the cloud service role to use in the yams configuration as the update domain for yams. So we have one-to-one mapping between yams update domains and cloud service update domains. That means that if we need to specify how the applications should be updated, we just use the built-in update domains from cloud service. Now, once we have the host deployed, and it's a one-off thing to deploy the yams host when we are provisioning a new environment, we then need to actually package the applications that we are going to deploy. On our project, we have 5 separate applications. One of them is Orleans silo, Orleans cluster. The other 4 applications are 4 separate web APIs which talk to Orleans backend and are exposed to either website or third-party applications which are integrating with our system. We deploy web app to app service, as we've said before, but the whole the rest of the system is hosted on yams. When we merge into develop or master branch in source control, we use Visual Studio Team Services to generate NuGet packages for each application. Because each application is basically just an exe with a bunch of DLLs, you can use either a built-in step for the NuGet packager to create the NuGet package, or you can use Octopack from Octopus Deploy. It's a NuGet package which you add to your project, and as part of the build process, it generates a NuGet package for you. So each of the applications that we have becomes a NuGet package, which we then push to Octopus Deploy NuGet feed. If you are using TeamCity, you can use the built-in feed in TeamCity where you expose the artifacts of the build through the TeamCity NuGet feed, and then you can get Octopus server to fetch those artifacts directly from TeamCity. We also use Visual Studio Team Services to create a release in Octopus Deploy. We are using Git version and Semver to name our releases in a meaningful way, and we have separate stable and unstable channels in Octopus Deploy, and we will push a release to unstable channel if it comes not from the master branch, and all the builds coming from the master branch are pushed to a stable channel in Octopus. Once the release is created in Octopus Deploy, we now need to deploy it to yams. Big kudos to Alex for creating a yams uploader that we are using. It's a very little tool that takes binaries which are sitting in a local folder and just uploads them to blob storage in Azure, and also updates yams deployment config file to specify that the new version has been uploaded and can be rolled out to yams cluster. We also have a custom step template which was accepted into the official Octopus library. That step template allows us to very easy configure our yams uploader in Octopus. So in order to specify which application should go, it's really just a few mouse clicks in Octopus UI. Ruben has his own yams deployer project. He has a very interesting feature in there where he only uploads files that have changed into blob storage, saving him some time on the actual upload from Australia. Because we are hosting all our infrastructure in Azure, we don't see any problems with just pushing all the files to blob storage every time. It takes literally just a few seconds, and the apps that we have, they are just a handful of megabytes big, so it's not a big problem for us. Now let me show you how the actual process looks like in Octopus Deploy. So this is our project. We have a few channels, an unstable one and a stable one, and the actual deployment process in Octopus Deploy is very simple. We start by using a built-in steps to install the NuGet packages. So we have 5 child steps in here, one for each YAMS application that we have. And all we do in this step is we're fetching the package ID from the built-in feed where we've pushed our NuGet package from Visual Studio. And we use built-in steps to replace some configuration settings in app settings or in other files or in JSON config files, so we can have different configuration for each environment. We are not actually using any tentacles. All of this runs on the Octopus server itself, as everything will be pushed to Azure Blob Storage. So the next big step is to actually deploy YAMS applications. So we start by fetching our YAMS uploader from nuget.org. We have our YAMS uploader hosted on NuGet, so we can get the actual NuGet package from nuget.org, and we can install it on the Octopus server as well. And then we use our custom YAMS uploader steps to actually publish each of the 5 applications that we have. So the only configuration that we need in here is first to pick the step where the YAMS uploader has been installed. Then we pick a step where which represents the application that we are installing. So in terms of our Onions backend, it's the install package application. And then we need to provide the very basic configuration for YAMS. So we need to specify our application ID. We need to specify the version, which by default is the version of the release. And then we need to specify the cluster ID, which is the deployment ID of the Azure Cloud Service, and the connection string to blob storage, where all the files should be uploaded, and the files in the storage which is monitored by YAMS for deployment. All of that is enough to get the application deployed. So if I show you the logs of that uploader step, you can see that we are using the previous steps to figure out where the YAMS uploader exe is, where are the files to be uploaded from. We then push the binaries to blob storage under the application ID, and here in the logs we show the config file that was there before our deployment. So you can see in here we have 5 different applications, and each of them has version 0.13 released. And after we successfully upload all the binaries, we update the config file, and you can see that the Onions backend has been updated to version 14. That is enough for YAMS to understand that the config file has been changed. The YAMS host will fetch the new config file, and will start deployment of those applications. So if I go back to our deployment process, we're pushing those 5 applications to table storage and updating the config files, and at the end we are pushing the web application itself to app service. Now there is one little thing that I need to point out. Just the fact that we've updated the config file doesn't mean that the whole deployment has finished. This is just the starting point for the yams host to pick up the new binaries and start pushing them to all the nodes according to the update domains that have been configured. So this is really the start of the whole actual deployment process. At the moment, we are using just our logging to see how the application is being deployed. To be honest, we haven't noticed any problems with yams, apart from my little mistakes when I was mistake when I was copying the deployment ID from Azure portal, and I haven't selected all the characters. I missed one letter from the end of deployment ID, and then I was trying to figure out why my application isn't deployed. But we had no problems with yams. It's picking up the changes, and it's pushing up all the applications according to update domains without any problems. I'll just show you very quickly the variables that we have and the configuration for yams. So those are the yams variables which are referenced in those upload steps. And you can see we have 5 different app IDs. We have a few clusters, and those IDs, they have to precisely match the deployment ID of the cloud service that is running the yams host. And then we have connection strings to yams storage. Again, different one for each environment. And on production, we have separate storage for green and for blue environments. So let me go back to talking about those green and blue environments. We have 2 separate yams clusters, one running in blue, one running in green. We have 2 separate web apps, and we have a traffic manager that we use to route the traffic either to blue or the green environment. We have 1 event store and 1 document DB, which are geo-replicated, so we don't need to worry about table storage or document DB being offline. And we have 2 all-ins clusters. We are only running 1 at a time. If we were to run both at the time, we will see clashes because the same actor with the same ID could be instantiated in both of those clusters, and then we may be getting errors when both of them are trying to write to the same stream in the event store. At the moment, if we need to switch between green and blue environment, it's a manual action that we need to do in the portal. We need to start the yams host on one side, stop it on the other side, and update traffic manager to the traffic to the new environment. We use that only for scenarios where one of the data centers our primary data center goes down, and we need to start the system in the other one. It's very easy because everything has been provisioned. And then the beauty of yams is that when we deploy the new versions of the applications, the yams which is sitting in, let's say, green environment, the host is stopped. But when we start the cloud service, the first thing that yam does is checks the latest version of the config file. So if we've done any deployments in the meantime to blue environment, the yams host, when it starts in green environment, will pick up all the changes, will pick up the latest config file, and will fetch and update the applications before they are started. In perfect world, we want to use the multi-cluster configuration in all-ins, and once we have distributed grains, then we can have blue and green environments running at the same time, because then the all-ins multi-cluster support will make sure that we will have no problems with running 2 instances of the actors in two different clusters. What we can do then is change our traffic manager to use the performance profile to route the traffic to the newest API and the newest all-ins cluster, so we don't have to worry about manually switching between the blue and green environments. We can then have more than 2 environments, we can then be running hosts in West US, East US, and Europe, for example, without any problems. Recently, we've noticed that Azure Cloud Services got a scaling settings ported from the old portal to the new one. So in new portal, you can now specify your scaling profiles. And this is the example of our test environment where during the day we are running on 2 nodes, but during night when we're not working, we just shut down one of the nodes and we're running on a single one. And then we just bring up the other node up in the morning. That allows us to cut down the cost because we're not using one of the nodes during night, and also help us with testing the actual scaling of yams and our applications which are running on yams. We haven't noticed any problems. Basically, Azure will bring one of the cloud service nodes down, yams will shut down. Next morning, that node starts up again. Yams picks up any deployment that may have been done during the night, updates all the applications, and starts them nicely. So we've been using yams quite happily with the scaling, and we haven't noticed any problems with it. So that's all for me. I wonder if there are any questions.
There are lots of questions in the Gitter channel, Jakub, but I think most of them are from Sergey, so I'll let him ask them himself.
Let me scroll up. Yeah, so the first question was sort of unrelated deployment. Jakub, you mentioned that you use geo-replicated table store, but recollection is that in case of failover, replicas are only available for reads. So even if you fail over your compute to another DC, you won't be able to write to a table until they become available again. Is that a misunderstanding, or how do you handle that?
Well, during the storage failover, once the failover is done, and we as the Azure customer have no control of it, that's all managed by Microsoft. The other replica becomes writable. You have the option to use the read-only mode of the secondary replica if you use that feature in table storage. So you may have access to your other replica in the read-only mode, whilst the primary one is being used for read-write. But we're not using that feature. We're not using the secondary replica for read-only mode. We're just using the bulk standard feature of geo-replication that when the failover happens, the other replica becomes writable.
Oh, okay, got it. I understand. Thanks.
So what we do at the moment is, with the table storage application, you have the data centers which come in pairs. So you have North, West Europe, you have, I think, East and West and US, which come in pairs. So we've deployed our blue and green environments to the same 2 data centers, which are paired using for the table storage geo application. So by default, we are running in the same data center where the primary copy of the table storage is used. So we're running the same data center. In case of the data center becoming unavailable, we are assuming that Microsoft will fail over to the other data center, and then we can start our infrastructure in this very other data center, which we know which it will be.
Got it. Thank you. I think the other question, and not just from me, people wondering about you, maybe you can drill more into the blue-green environment, why you use Into and how you use Into, and also why not connect them with a VNet, for example, to have a single Orleans cluster, if you look at that.
Well, at the moment, we don't necessarily need to scale the application globally. We don't want to run, I mean, we started the project before the multi-cluster support was introduced to Orleans. So right now we're running on a single cluster. We don't necessarily want to run the application over VNet between two data centers. So we are using, for example, fan-out queries between actors. So we don't want to end up in a situation where half of the actors are running in one cluster in one data center, another half of the actors are running in a second data center, on the other side of United States, and then we're doing a fan-out query which goes, over the over VNet between data centers. So for performance reasons, we want to make sure that we run our application in one data center at a time. That blue-green deployment is mainly used for ensuring business continuity in case of a data center going down. We don't actually plan to switch to the other data center unless it's really necessary because the primary one is offline. Or maybe if we need to make some fundamental change to, for example, we want to update the yams host or something like that we would like to do on a separate environment without taking offline the primary one. But on a day-to-day basis, we run in one data center and we have everything running from the same DC.
And you're thinking about using a geo multi-cluster for blue-green. Did I get it right?
Yes. So once we have event source actors in Orleans, I hope it will be in the near future. Then what we can do is link those two data centers together and have a multi-cluster deployment, which then will be running at the same time in both data centers. That's the ultimate goal.
Perfect. That's great. Thank you.
Jakub, it's Richard. I was curious to know which features of Orlea Akka you were making use of. Why did you go down that route rather than using vanilla Orleans? And it's a loaded question. What do we need to pull from Orlea and Akka to make Orleans a better choice?
One good feature is the support for testing. Even has implemented a really nice testing kit for the actors, so we can mock the runtime, we can mock reminders and timers, we can mock other actors. So it's really easy to create a unit test for an actor without having to start the whole silo. So there's no need to start the silo in the process of the testing framework, and then you can very easily mock the responses of other actors that the actor you're testing is talking to. So for the testability point of view, Orlinka has really nice support, which I would really like to see in Orleans itself. Another feature is being able to easily create an actor which implements commands and queries. So we use event sourcing and we use command query separation for most of our actors. So we can easily define the interface for the actor by creating messages which are commands which will change the state and queries which will not change the state but can be executed in parallel by the actor because they have no side effects. So those are two main reasons for using Orlinka in our project.
Cool, thank you. I'm also curious how you walk up and down versions. So you kind of walk through how you upgrade, but is there a downgrade path, or is that handled
Oh
all
yes,
for you by Octopus?
downgrade path is really easy. So if I just quickly jump, I hope you can still see my screen. If I quickly jump to our overview, you can see that, for example, on test environment we have version 14 deployed. If I want to downgrade to the previous one, I just deploy the previous version. What will happen is we will fetch the version 13 of NuGet packages. We will try to push them to blob storage. The actual yams deployment tools that we are using, we are actually the yams uploader that we have is actually using yams itself to publish to blob storage. So we specify the conflict resolution to ignore, because version 13 has already been deployed. The binaries have already been deployed to blob storage. We don't need to deploy them again, so nothing happens in that step. And then the yams uploader, we just update the deployment config file and put version 13 instead of version 14. And again, yams will just pick up the change to the configuration and will deploy version 13 to all the applications, again adhering to all the rules of update domains.
Okay, Jakub. Hello, guys.
Go on, Gutenberg. Yeah, do you have a question?
So yeah, you say that you can easily revert to a previous version. It's pretty easy with yams, yeah. I used to use it in my previous project, but the main question I think from Richard is how do you, if from one version to another, you are changing state? I mean, upgrading, adding a field or something like that. How can you revert or even upgrade when you have to deal with state between those versions? How do you deal with it?
Well, obviously, the problem is with migrating the data between versions. So that's always the problem with when you have some persistent state. We're using event sourcing, so for us it's a bit easier to not introduce breaking changes between different versions. If we've deployed version 14 and we've introduced a new event and now we have that event persisted in the event stream. If we deploy a previous version of the code, we will start getting a lot of warnings in in our logging to say that, oh, the previous version of the actor, while reading the event stream from the event store, noticed the event which it doesn't know how to handle. So we won't fail in that case. We will get warnings, so we know that we are not processing, not understanding all the events that were persisted. And now the question is, what is the actual business logic that is driven by those events? I mean, downgrading or upgrading always has the problems of what to do with data. So if you've made some really breaking changes, then at some point in time you can't really roll back to the previous version unless you have the copy of the data. With event sourcing, you have the copy of your whole data because you're never modifying anything, you're never deleting anything, you're only appending new events. So with event sourcing, it's a bit easier to support running older code against newer events because you just skip them and that's pretty much it. When it comes to projections, we have the way to rebuild all the projections. So we have a bit of infrastructure code that will trash all the documents that we have in DocumentDB. Will load all the streams and process all the streams with the events from our event store, and we can push them through our projection actors, which are responsible for building and updating documents in DocumentDB. So we can rebuild projections very easily. Obviously, while we are doing this, the environment will not be available because you need to stop the system, you need to delete all the documents and recreate them from scratch. But there is a possibility to do that should something really terrible happen. Because with event sourcing, you have the whole history of all the changes in the system. If you're using if not using event sourcing, if you're storing your actor state as blobs, maybe you could use proto buffers, and basically you need to serialize your state in such a way that you can allow for the older version of the code to work with the newer version of the data in order to support downgrades.
Yeah, yeah, that's good. Basically, so he built the whole state of the application, ignoring or by logging some unknown types. Like, so I assume you reverted that the application, you don't have that type to the serialized event. Okay, I got it. Thank you.
Mm-hmm. Any more questions? I'm trying to look at Gita at the moment.
Oh, I think Attila was asking about whether parts will be open sourced, or which parts are open source, I guess is the question.
So we have our yams uploader, that's open source. There is, if I just go back in here, there's a link to our GitHub account where we have our yams uploader. The actual NuGet package for yams uploader is hosted on nuget.org, so you can fetch it from there. The package name is applicita.yamsuploader. The step template is sitting in the Octopus library. So if you're using Octopus, just go to library, type in yams, and you will be able to find it really easy. I think the very latest version of Octopus, which was released, I think last week or maybe even this week, has a nice integration with the library. Before you had to copy paste the custom step templates yourself. Now they've integrated it within the Octopus UI itself, so you can very easily search for the templates. The yams host that we are using is pretty much a copy of what's available on the Microsoft Yams account, the documentation. That doc has basically the whole cloud service role, the source code for the cloud service roles that we're using. All we've added is support for Serilog and pushing the logs to Seek, so we can see all the logging from Yams in one place.
Thanks.
My question here is that cloud service host. Maybe it would be worth to put this as a NuGet package, so I can very easily reference it from my cloud service. But it's literally just a few, couple of files, a few lines of code. It's probably good enough to just copy paste from the Yams documentation. I've noticed that Sergey was asking if we are running all our 5 applications on a single set of VMs. On lower environments, yes, we have one YAMS cluster where we are running all 5 applications on, so we can really use our resources in the efficient way. On production, we have one cluster which is hosting only YAMS, the backend, and we have another YAMS cluster running on another set of VMs, which is running 4 APIs. They are sitting with different subnets of a VNet. This is purely for security.
Thank you. I'm curious if you looked at containers for isolation as well. I know Gutenberg has been playing with them and kind of looking at them as well. So I'm curious if you guys looked at containers already.
Not really. At the moment, we find it really easy to just get our binaries, put them in the NuGet package, and then push them to blob storage. The NuGet packages are really tiny, and we have really no problems with having to provision, the cloud services once with the YAMS host. Obviously, you could put everything in the container and have and use Docker containers to deploy that, but we haven't noticed any need for that at the moment. We've recently upgraded, our cloud service from Windows 2012 2016. It was just, a change in the service definition file. Just published the new version of the cloud service. Job done. No problems at all.
Yeah, regarding the containers, I think today YAMS hosts all the services from the configuration file in separated process. If we think that we can install the YAMS agent on a container host, let's say the Windows Server 2016, and then instead of starting new processes, it can start in new containers. We can achieve the same thing, but keeping the container benefits like the isolation, the network separation, etc., that comes with the container.
Yes, that's definitely something you could do, and yes, you get the benefits of this additional isolation. At the moment, we didn't have the need for that. We have one system, and all those 5 applications are part of the same system. We're not running any third-party applications mixed in the same cluster with our own applications. So there's no need for any additional security. We are always running the same version of Windows host for all our applications. So when we've upgraded, for example, to 2016, we've upgraded all of them in one go. Yes, the containers will give you more isolation, more flexibility, but for this project, there was no need for that, and we didn't want to spend too much time doing something just for the sake of doing it.
Yeah, thanks. Makes a lot of sense.
Just out of curiosity, what's your deployment time from start to finish?
Well, if I look at the logs, 2 minutes for everything. But then remember that this is to start the actual deployment of applications by YAMS host. So this is to push everything to blob storage, change the config files, which will trigger the actual deployment, and deploy the web app to app service. The actual deployment of the applications is basically how long it takes to start All-in Silo for the All-in's backend. Web APIs, they are web APIs hosted on All-in. It takes literally no time for them to start. It takes maybe 20 seconds or so for that. And again, the rollout of different update domains, it's pretty quick. So you don't have a case where you've deployed application to update domain 1, and then you're waiting a few minutes before YAMS realizes that it has to update another update domain. It happens really quickly, one after the other.
Cool. And are you one of these places where you deploy several times a day, or do you schedule for kind of overnight,
yes,
so you have minimum disruption?
No, we push to our development environment pretty much every time we merge into develop branch. So we have a few pull requests per day at least. So we get quite a few deployments done to development environment, plus pushing it to test, plus pushing to UAT. What would be really nice to have, and I think the YAMS guys are looking into it, is to get a tighter integration with All-in Silo. So we could get the notification when the silo actually started, and yams could actually understand when the application it's deploying has actually finished the deployment and is running now. I think they've mentioned during the meetup that they want to integrate that deployment of done by yams with Azure load balancers, so the load balancer can be used not to route traffic to the application which is being updated, to the update domain which is being updated at the time. That would be really nice. What sometimes happens, what happens at the moment is the API takes next to no time for update. The all-ins silo takes a bit longer to update. So we may get the API up and running, trying to talk to the silo, while the silo, for example, one of the silos is starting. So if you have multiple silos in your cluster, that's not a problem, because the other silos will be running. If you have only one silo, then obviously it will be, when it's down, it's down.
Sure. How frequently do you deploy to production? Because I mean, there's a cost in deployment, isn't there? Because you basically lose all of your activations because they have to be reactivated in the new process. So is that something you try and do as infrequently as possible, or?
At the moment, we don't have the live traffic going through production at the moment. We're not fully live yet, so we're deploying to production at the end of our sprint, which takes which is a week. So there's no, we haven't faced the problems of deploying the application which is running under a heavy load. So I can't tell you anything about that yet. Wait till the beginning of next year, and I'm quite happy to come back and update on what's going on when you have a lot of traffic going through the system. For me, I believe that the solution would be to have a lot of update domains, so running on a larger number of nodes. So then you have multiple silos, and you're not bringing down half of your infrastructure. You're bringing maybe a fifth of your infrastructure down at a time. So at the moment you will be losing only a smaller percentage of your activations. Maybe we need to make sure that after one update domain is updated, yams actually pauses a bit and waits for the activations to settle down before updating another silo. That would require the tighter integration between yams and all-ins, so the yams could understand when the actual silo has finished updating and is running. That may be something that we'll be looking into in order to support deployment under heavy load. Fortunately, in our project, we should have quiet nights where there's much less traffic. So we'll probably be just scheduling deployments during night where the traffic is much smaller to solve those problems.
Sure. Well, it's interesting when you're actually doing the deployment, you have silos running different versions of your code, i.e. different versions of your classes. So there could be scenarios where you're sending a message from one grain to another and the class has changed. So do you have to be careful when you modify your messages that you only include extra fields that the serializer can handle? And my next question, which leads into this, is how can you test that? Is it one of my customers is like, I want to be able to test that messages can deserialize and serialize when their versions have changed, and that just opened a big can of worms about how to do integration testing rather than unit testing.
You could try to write a unit test for it, but in our cases, I mean, at the moment we are mostly adding features rather than removing them. Even with your new silo being so if you're looking at the two versions of your code running at the same time, because you've updated one silo in the cluster, but the rest is still running the older version, the new activations of the actors in the new silo will be running new version of the code. If they start publishing or writing new events to the event stream, they will be used only by those actors which were activated in this new silo. So hopefully we won't run into a scenario where we've activated a new actor in the new silo, it wrote some new events in the event store, then got deactivated, and the runtime activated the same actor with the same ID on the old silo that hasn't been updated yet, and it tried to load the events from the event store. Obviously, it wouldn't know how to understand that newer version of the event or the new type of the event. We make sure that we don't fail in that scenario. We get we log warnings that an actor has is loading its state from the event store, and it noticed the event which it cannot deserialize properly.
Jakub, I'm sorry. So I think you're going right into the topic of our next meetup.
Yes.
Excellent.
Today.
A nice lead into it then.
Yeah, so it's like a natural segue.
Yes,
let me make a last.
I think it is. Versioning is something which Orleans doesn't do explicitly at the moment. We as the application developers, we need to worry about it. And I think what really helps is making smaller releases more often, where you have a smaller amount of changes. And also, if you're going to make breaking changes, or if you are redesigning your state or redesigning your actors, it's probably better to think about making few releases where you can first push the release that kind of prepares the old version of the code to understand how the new version will look like. And then you can push the new version, and then you know that even if you get the activation in the old silo kind of has the view of the future and will understand how to deal with something it cannot cope at the moment.
Let me ask you something, Jacob, just for the curiosity. I see that you are using Octopus, etc., and you are promoting the deployment from one environment to another. And I wonder, did you ever try to or evaluate the Visual Studio Release Manager on VSO?
No, we haven't used Release Manager in Visual Studio Team Services. We've always been a fan of Octopus Deploy, and we've used it before. On other projects, even if we were using TeamCity, I would usually just hook it up to Octopus Deploy, just for the ease of setting up the release and having the library of all the custom steps available. I'm pretty sure you can do all of that in Visual Studio Team Services. You get these steps for all the NuGet packaging and so on and so forth. All you need is just the way to unpack your NuGet package to some local folder, run any changes to configuration which are specific to your environment. Octopus does it brilliantly with the variables and the variable substitution in different types of config files, XML or JSON. It runs XML transformations nicely if you have those type of configuration in the code. And then it's just a matter of pushing those files to blob storage, which at the moment we have our own custom step, which is a bit of PowerShell that calls an exe. I'm pretty sure you can do that in Visual Studio without many problems.
Yeah, it was, like I said, it was just curiosity question, because we did that in the past, and we were pretty happy actually with the TFS. We have all the tests, just like you have there. We build the code, test the code, and push to one environment, and we actually even integrate with the Azure automation in order to create more VMs or something like that, based on some criteria from the build definition. But it's okay. Thank you.
It's basically Octopus Deploy was the tool that we were very familiar with, and we didn't want to start investigating the release management in Visual Studio.
Yeah, sure.
Okay, I think it's 9 p.m. sharp
Yeah,
over here.
we reached the end of the hour.
Precisely an hour, which I think is the time to say goodbye for us, and hopefully we'll let Sergey talk about versioning of Olin's applications during our next meetup.
Sounds brilliant. Thank you very much, Jakub.
I was thinking, Richard, if we have like a minute left, we could just maybe show a teaser for what we're going to discuss, but also just stimulate some thinking and ask people to come with ideas and proposals and to discussions.
I'm sure we have a minute for you, Sergey. Yeah.
So let me try if I can present really like a single slide.
By the way, thank you, Jakub. That was a really good presentation and very interesting. So, thank you for that.
Can you see it?
It's loading. There we go. It appears for me.
So the goal there is to start with sort of lay of the land, kind of mapping of what set of problems involved in quote-unquote versioning. It's kind of evolution of code, of data types, their compatibility on the wire and storage and queues, and sort of related DevOps experience aspects, like upgrades, rollbacks, A/B deployments. So the plan is to kind of discuss the problems and then go into what's actually in the works right now. So we just merged support for heterogeneous silos, which is an enabler for a number of things like Downgrade. Yeah, and this drops of liquid you see on the slide is tears of developers have been suffering from lack of versioning support.
And the sweat of the team working on the new features.
Yeah, the community. Yeah, so that's the teaser, or I guess the trailer for our next meetup, which will be sometime in January, I guess.
Yep, sounds good. Okay, thank you everyone. And we'll meet again in January and pick a date. It sounds like Sergey's going to be presenting, so we'll look forward to that.
Oh, and Benjamin, maybe somebody else too.
Cool. Okay, thank you all, and farewell, and I'll post the recording up onto YouTube shortly.
Yeah, and thank you, Richard, for hosting, organizing, recording, posting, all that.
Pleasure, no problem at all.
Of course, thanks to Jakub for presenting, first of all.
Cheers, goodbye.
Yeah, bye-bye.
Thank you, bye-bye.